Good morning, everybody. My name is Vesa Tianen, and now I have received the second flow simulation of the solar heat collector, which I have been designing. And thanks to EQM Sol again and Carver Camde for making this simulation possible. So the basic design is like this. So there is now added the fan, and I have shortened these ribs a little bit and make the wedges here, and inlets are triangles at the bottom and outlets are triangle, a little bit like this kind of not straight line pattern. The 140 millimeter fan can produce 2.27 meters per second maximum speed. That's what we have put here. But the fan is in this simulation only standing still. And here is also the air divider plate, which has 18 millimeter holes in it to make it distribute the air more even inside the chambers. So here's how it looks now. This is the visible side, which is again named as backside channel section. Let's go through first that one. The hole pattern seems to work like it should. It makes the air more uniform on this side after the holes, but before the holes there's these areas where there is too little airflow going at the moment. On the underside, where are the four chambers, it looks much better. You can actually see the turbulence the holes are creating in the results, which is good. But you can also see that when I made this shorter, it didn't correct the problem totally, because there are tears on both sides. You have these sides or shapes where there are no flow. On the center channel, it seems to work quite good, because this is now not creating the pockets on both sides. This is caused by the fan, actually, this problem here, and also this area is mainly due to the fan design shape. Air goes nicely on the lower side. Here also a little bit on the corners, which was expected. This, which I make it shorter, made it a little bit better. It's not so big, this gap here anymore as it was. So here, making the rib shorter worked quite well. I think that is already so good. I don't do no changes there. The corners, it doesn't matter here if the air is not going to the corners, because on the top side the exit is there, so that air will go through there 2 times, and that will keep the aluminum foil cool. But these pocket issues I need to solve. It's not going to be helped or solved by if the fan is actually rotating. I think these will come anyhow, so those need to be solved. Also, you can see the airspeed is much higher from the color, 4.5 meters per second even here through the holes. So you can actually see from the speed results that there's more air going to the underside, and on the visible side there's less air going. And actually that is causing these swirls here, because there's too little airflow. You should have about 60% air going to the visible side, and that's not happening at the moment. Same goes here. The air goes the easiest route and avoids this route at the moment. Another chart showing pressures. Here you can see again the swirls it's creating. You can actually see that the swirls are going quite long in the chamber, so it works pretty well, the nozzle design there. But here you can see some of the problems. So the fan is right before the air enters the chambers and it's not rotating at the moment, so it's only making the air go sideways. I will show more clear picture later on. So that's causing a little bit of the problems. You can see here why here is no air going here, because the fan is blocking the air going here. It accepts at this position where it's standing still, air go here, and the next fan blade will actually push the air more this way. So it's not going next to the rip like it should. So that will be solved. Again, some nice streamline animations. Now, if we start to look here, what's happening? The air is coming on. This is the visible side, and air is coming through these triangle holes. And what it actually does is that the air fan, most of it is on is there. So air first has to go this way when it comes to the holes, and that's why it now flushes to the back wall, and it has momentum to go this way, and that's why most of the air goes through the side walls first, and after that you can see how the baffle plate here works. It makes it sure that most of the air goes through these holes because it divides the pressure almost evenly here like it should. But for this problem, what you can see here, that air goes more this way, we have to do something about. The center hole is a little bit blocked now by the fan plate, so that's why there is not coming so much air here. But let's go more about that in the future. On the underside, it actually works quite good. You can see again which direction the fan blades allow the air go, because it's still. So one blade goes like that, and one blade allows to go air like that, and next blade allows the air go to the top channels. And same here on this side, it allows to go that way, and that's why you have the swirl on this side. But on this side, the fan position is so that it allows it to go right next to that, so there is no flow problem actually here. Shouldn't be. It's only on this simulation, so this swirl is not actually there if the fan is rotating, is my estimation. Here you can see again, fan allows the air to go this way mostly, and it goes the easiest route, and then it starts to divide again the baffling plate there, the air evenly, so it pulls the air towards that. Same on this side. So it works like it should, but to solve here, on the other hand, you have the problem that you will have the same similar pockets that we had seen on the first simulation on both sides. So I think we need to move the baffle plate right here, because after that the flow is nice and even everywhere, and it will solve many problems. Here, if you look again how it goes out from the chambers, it works quite well, but still most of the air is going through the center of the holes. But that's mainly caused because air will go to the easiest route, and now there's too little airflow going here, so that's why it's not flowing so nicely there. I will do more calculation on the hole sizes. I think I will add more holes to the entry side to get better distribution before the baffle plate. What else? Yeah, those are the things. So how much airflow was going on which side? So on the 4 channels there were 62.4% air going to the underside channels on these 4 channels, and you can see the center channels are a little bit more airflow. It's pretty even now. It was much worse, but still I think I will add little or change little bit smaller holes on the baffle plate on the center channels based on these first two simulations to get even better flow distribution on the underside channels here on these 4 channels, and on the backside flow 37.6% was there, and the target was around 60% of air should go there. So there's huge gap there, and the problems probably is that there's now too many restrictions for the air to go. First, the fan which directs the air more sideways is not now coming so straight to the channels. Even if the fan is rotating, it's pushing it straight against the aluminum foil, so it's not exactly like it should. After that, there's these triangle holes making a restriction, and after that there's this baffle plate making a restriction, and still in the exit you have one restriction. So you basically in this simulation you had 4 times restriction for the air that goes on the visible side channels, and that is causing some problems. That's why I will probably for the next simulation change a little bit of that so it can more freely go before the baffle plate. There is some pressure drop more than in the last design. Maybe some is explained by the fan and also the restriction plate there. And what has designed between the old and new one? This is the old one. You had straight ribs and no fan there. And here I had a square entry hole to the visible side. Now I have, was it 7 triangle holes on both ends, and the fan is there, and the rib and the baffle plate. In this design, on the visible side, there was about 30% area which didn't have no airflow in the first simulation. If you look the current version, it has got much better. I would estimate now there's 15 to 20% where is no air flow almost, so it's 10 to 15% better at the moment. But after the baffle plate, you can see it's much better. If here would be a little bit more air going here, close to the 60%, this would be almost uniform color also, and same goes here. So the baffle plates solve the problems like it's estimated. Then on the 4 channel side, there was these huge gaps on the sides as after the ribs, and for that also the baffle plate makes the air go tighter route, so it will solve the problem if I move it here, and after that the air will then go to the top end of the collector. You can see actually these swerves here are quite long. It's almost already here as long as the collector here, 1.5 meters or something, 1.3 meters. It's swirling. You can see the swirls in the color. And actually I now notice that I'm explaining with the mouse on the wrong screen because this is not correct. The bigger screen is easier. Sorry for that. So here you can see very clearly how the fan plates make the air go. So if I move this baffle plate cursor here, these gaps won't have chance to come, and these swerves which you see here that don't have airflow, I think it's moving a little bit, so it's not that bad kind of pockets, and if they are so narrow, the aluminum will even out the temperatures there better. If you have big pockets like this, it will get very hot, and it doesn't matter even if on the other side there's nice airflow. basic idea is that top side and underside airflow will even out the results of the simulation. So it shouldn't have pockets, two pockets on either side of the air. Again, some streamline pictures, some comparisons of the pressures, not much here. And on the visible side channel, that there was more turbulence there, which was the target, so it's doing quite good. But also there's less air going there, even the target was to get more air there. So I need to do something about that. Same here, notices that the fan might cause problem, the triangle openings might cause problem, and the air divider plate might cause problems. I think the main problem is at the moment that I need to make now sure that there is, before the divider plate, there isn't so much restriction, because the divider plate purpose is to make the distribution between the upper and lower channels. So there's the flow numbers are like I should, so I will add more triangles to the flow on this side. So now I have the 7 triangle holes before the baffle plate, and I will add more here, and the shape pattern I will make it like it is here. So one hole is like there, and now it's right at the edge of the entry hole is right at the bottom of the plate. I will try to make it so that I will take it a little bit up. That's why the air will have chance to go make a U bend. Now it goes up, and that's to go then this way, so it doesn't go so easily this direction. It has momentum to go sideways, so if I make it a little bit up, it has time to make a U bend and hit from the back wall and change direction, and then it probably will more nicer start to go this way. But if I put the baffle plate close to here, it doesn't have much time to make these blue pockets here where there is no circulation. And here you can see the angle which the air is now diverted from the fan is maybe 20-25 degrees. Normal mode, when the fan is rotating, it pushes the air straight up, so it's not exactly like it is at the moment. When it comes to the exit side, I think there I need to make on the visible side the triangle so that it pulls a little bit more air towards the side, so the corner triangles should be a little bit bigger. Then it will make the air more willingly to go on the corner holes, because it has more easier route there. So that will help with this one, and extra flow which is here in the visible channel will also make it go more towards the end straight line, which is better. So that's what I will change for the next simulation. Yeah, thank you for watching, and if you have any ideas what would you do to make the simulation better, let me know in the comment section, and I think we will do at least one more simulation and see where it takes us. Thank you.